All right. So first, thanks everyone for staying this long. I know I'm the last person between you and the reception and poster and everything. Try to make sure the story is pretty sharp. So my name is Wei Lu. I'm assistant professor of marketing at Baruch College, City University of New York. And today I'm happy to present my work jointly with Daniel Chen from Toulouse and Chris Hansen from UChicago. So we have enough background about the future of AI, and so I just want to cut it short. So what would happen if this generative AI stopped being just being an assistant, but move forward to be part of the AI agents, or what we call agentic AI? We know in the last few months, like these leading companies have introduced this AI agent function where users can leverage the tools and build their own models that can think individually and act on their behalf. Some of the interesting applications we have seen in the past few months include vibe coding, which is for people who have zero experience with programming. You can just simply rely on AI to create your own app just by using natural language. Or something more risky, like Anthropic introduced this project Vend, where they are using the cloud model to act as if it's our own vending machine by interacting with consumers and suppliers. And looking ahead, the next iteration will be something more riskier, where these AI agents do something that's automatically on their own, where they will interact not just with users themselves, but they will interact with other AI agents or other humans in the so-called strategic interactions, which the outcome of these actions are jointly determined by the agent itself's information, its own incentive, its own actions, as well as the other party's decisions and informations. So the 2010 flash crash is one example when this small errors of AI of this pricing algorithms can cascade into something causing billions of losses in the financial market in just a few minutes. And most importantly, one thing I want to point out is that this kind of risk is more of a structural risk. It's not based on any malicious intent of individual algorithms. Just by design of the interactions of these agents, sometimes it may go off the path and do something that creates tremendous risks to us businesses and consumers. So how can we ensure that AI agents can behave according to some intended preferences or goals is part of this research project. And one thing that when you think about using agentic AI as of this current foundation model in this kind of strategic interactions, there's the potential limitation of how these models are trained and why it may fail in certain cases. As many of you are already quite familiar with ChatGPT, and in many cases, you will be facing the scenarios when after you ask a question, the model just returns you two types of answers, asking you which one you like better. This is something that computer scientists know as reinforcement learning with human feedback, where the model, after it's been trained, in the fine-tuning process, it's been fine-tuned based on users' preferences of individual answers. And the goal for these models, for this post-training fine-tuning process, is to make AI agents to be helpful, honest, and harmless. And we know that it's been incredibly effective, like ChatGPT, that this kind of generative AI thing is becoming a must in many people's daily life. But there's something that the current alignment strategies may overlook, which is the strategic elements of it. Like in cases when your AI agent is acting on your behalf in these kind of complex strategic interactions, it can just simply be helpful, honest, and harmless, like pricings, like negotiations. You don't want your AI agent to be nice to the other party for most of the time. So there's a gap that we would like to address in this project. So feedback-based alignment sometimes emphasizes what users like based on this ratings or like thumbs up or down from user data. But strategic environment requires what preferences and incentives dictate, which means that you need to have an internal structure of some kind of preference that is guiding the model towards the intended goal set by us. So in this paper, the main question we want to address is, can we systematically align LLM agents so that they act with interpretable, predictable preferences in strategic environments? The answer comes from economics. We know over the last 50 or 40 years, behavioral economics, game theory, they already offer a rich family of utility models that try to capture human preferences. These models can capture key patterns in human strategic decision-making, and given this rich theory, we also know the optimal strategy given the payoffs and the reasoning, the so-called chain of thought reasoning or economic reasoning is very clear. So to show that we can leverage economic theory in terms of fine-tuning agents for economic preferences, first I want to show you is that these foundational models, while they are being very competent in individual user interactions, can sometimes fail badly in strategic environments. And the simplest evaluation we can run is to ask these models to play economic games. So in particular, we tested GPT-4o, which is kind of the state-of-the-art foundation models at this time, on 3 canonical economic games. Sequential prisoner's dilemma, where both parties can choose to cooperate, but if you defect, you gain more benefit while your opponent is cooperating. But if both of you choose to defect, both of you thugs. And you can think of this as a pricing wars or some kind of repeated interactions. And trust game, which is kind of like investment, where the one party can choose to invest, and the other parties, when their turn, they can decide whether they want to return the investment back to their client, or they can just keep the money for themselves, which is a test for trust and reciprocity. And finally, ultimatum game, you can think of as take it or leave it negotiations, which tests the morality of different kind of agents. So the advantage for these economic games is that they are classic, widely used in behavioral economics to review motives like self-interest, cooperation, fairness, or morality. And each game was, in particular, each game when we were running, we presented the GPT-o the same set of instructions as we do to humans. That's then another advantage, which is that we can have the ground truth from humans for comparison. So in each kind of this game theoretic protocols, we provide the model its own we measure the model's own strategic choices given the payoff structures and the description of the game, and its beliefs about what the other player would do. So the main finding for the first part of our analysis is very interesting. So if I think about the sequential prisoner's dilemmas, for humans, which are illustrated in the blue bars, you can see that on average, if they were the first player, they will not tend to cooperate as much as we thought, right? Only about 30%. And if they see the first player is cooperating, while being a second player, they also have incentive to defect, right? Because that will give you more benefit. And if you see the other party defect, certainly you want it to be defect as well. But GPT-4o is completely doing the opposite. It just chooses to unconditionally cooperate in both cases. It will always cooperate. Only when it's pretty sure that it will not gain anything by cooperate, it will stop. And secondly, what I want to illustrate is that if we're comparing the beliefs and the actions of humans, their beliefs and actions tend to be more aligned. Like what they are doing by themselves is similar to what they're expecting what the other party would do. But the large language model is not capturing that. It's assuming a modest belief of cooperating, but it's cooperating by itself all the time. The same is true for the other two games, like investment games and ultimatum games. LLMs always cooperate, excessively cooperating, and insensitive to payoff structures. So if you're looking at the data by different game protocols, humans react given different payoff structures. So if the payoff for cooperating is higher, I would I will be more likely to cooperate, but LLMs don't. They just cooperate regardless of the outcome, which can be problematic in this kind of situations. So the main contribution for our project is that we introduced this fine-tuning process leveraging economic theory. So in short, we are teaching AI how to play economic games. And specifically, we consider two agents. One is the Homo economicus, which is the rational agent. And the second agent, which we call Homo moralis, considers outcomes when both players adopt the same strategy. So, which is kind of have this Kantian philosophical flavor about universalizability, that what if everyone did this? And so the way we construct the fine-tuning data is as follows. It includes a system prompt, describing the role of the agent, and a simple user prompt telling them that this is a game they have to make decisions. And most importantly, so we leverage this economic theory to include a whole chain of thought economic reasoning for playing each kind of these games, given the payoffs. So here, for example, the agent is learning to make decisions first at the second player and then at the first player. And for each agent, we use about 400 samples per agent. So the result is pretty striking, that with only 400 samples costing $50, you can shift the behaviors in a meaningful way. So the agents achieved a much higher internal consistency, whereas 80% of their strategies are aligned with their beliefs, whereas for the baseline GPT-4o, only less than 20% of their actions are aligning with the belief, if we assume that it's a rational agent. And specifically, the rational agent behaves like a rational person that we will assume, whereas the moral agent does take into account this Kantian morality concerns. Okay, so because of time, I'm gonna just focusing on very short applications where we want to test whether this fine-tuning process can generate out-of-sample predictions that are meaningful. Like, we just don't want them to play economic games. We want to see what will happen if it is used in another scenario. So the first application is the moral machine experiment. So this is not a strategic environment, but it will be interesting to see how the AI is performing. So in each of the scenarios, both humans and machines are asked about the question. So assuming you are in a car, and either your family member or your coworkers are on the road, some pedestrians suddenly shows up. What do you want the self-driving car to do? You want it to swerve on the ground, causing casualties of passengers, or you want them to go straight ahead? So then the most interesting thing here is that humans exhibit this kind of social dilemma where for the first two questions, either it's appropriate for the cars to save more lives. Yes, humans believe that 60% of the time it is the right choice. But if you're asking them whether you want to buy such kind of vehicle or more selfish autonomous vehicle that protect the passengers, people are more inclined to the passenger saving vehicles. The baseline GPT-4o is unconditionally sacrificing itself for all the time. It's very good for them to do that, and they are very less likely to buy this passenger protective vehicles, but they are voting highly for the maximized life-saving vehicles. But for the rational agent and moral agent, well, both also does not have this kind of moral dilemma as the baseline models. They do exhibit a significant incentive sensitivity. For example, the rational agent, when it's talking about saving maximized life-saving autonomous vehicle, is much less likely to choose that if their family member is in the car. And for moral agent, there's no difference, because from a Kantian point of view, either your family or coworker sitting in the vehicle doesn't matter much. But if you are facing the scenario when you want how you are willing to buy this passenger protected vehicles, it shows more – higher probability of doing that. And because of time, I just briefly skimmed through the results here. So we also tested whether this rational and moral agents can reduce algorithmic collusion in algorithmic pricing scenarios. And the answer is actually yes. So baseline GPT-4o has definitely are colluding in the middle. Rational agents are exploring, they're also colluding, whereas the moral agent kind of like pricing in a large sense, like even below the competitive price levels. So in summary, in this project, we propose a replicable, cost-efficient, and interpretable fine-tuning method for AI alignment for strategic decisions. We show that economic theory can systematically inform AI agents fine-tuning by synthetic data construction and economic reasoning. And it's cost-effective. Like with only 400 examples, you can observe meaningful action shifts. And it's extensible to other utility models and preference structures as well. Okay, and lastly, one interesting thing I want to point out is that when we are testing O3 and O4 mini, these models tend to act perfectly as a rational agent, so highlighting that there's a potential for further tuning the model after the training process. Okay, I think that's the end of our talk. So have a good day. Yeah.
Although people think being rational is like the optimal choice, but in the real world, usually it's not that, it's contextual based. For example, if I play distrust game with my husband, I will always betray him. If I play with distrust game with my son, I will always, trust him. So how would I know that what is the optimal choice? Rational is not always the
Yeah, certainly. So rationality is definitely not the only thing we want to pursue. That's why we incorporate this moral agent as the middle ground between like a perfectly altruistic LLM versus a rational LLM, I think. And also in your case, you're probably talking about the context of different games. I think that's something that's interesting to explore. Like currently, we are abstracting from the specific context by instead focusing on specific utility structures. That's what we're doing. Yeah. But I think it'll be interesting to see how in-context learning can affect the results. Yeah.